Okay, 15, operations with functions. So operations. So what we call the simple operations, add, subtract, multiply, divide. We create new ones, evaluate them, determine their domains, and then composition or compose functions. Okay, that's kind of the newish one. And then decompose, even newer. So basically put two functions together and then take two functions apart, really what that means. So our operations are first for our addition, subtraction, multiplication, and division. So basically you just can split them into their two like separate entities, if you would. Okay. Basically you are just performing the operation on their y values. So you have to have the same. So graphically, basically what happens if I give you a pretty picture, like let's say I'm drawing two functions on the same graph. And I'm making this up on the fly, so this is never really that great. This is 1, 2, 3. Let's just say the first is just y equals 1. Okay, just make my life easier and your life easier. And then maybe the next function is a linear equation, say y equals x plus 2. Let's make our life easy, okay? I'm all for that. Then if I like add them, subtract them, multiply or divide them, then literally you are just adding, like if I were to perform it, this would just be 1 plus 3 to get 4, essentially. And then it would just really just be this line, just 2 units up, or yeah. Because if I have 1 plus 2 is 3, plus 1 is 4. And then if I have, say, 2, so f plus g of 1, I should do that in green. F plus g of 1 would be 1 plus 3. So f plus g of, say, 2 would be 1 plus 2 plus 2, which is 4. Let me get this here in the red, 4. So then that is 5. So you don't have the point 2 comma 5. So 1, 2, and then 1, 2, 3, 4, 5. Okay, but pretend like I can draw. Pretend like I can draw. So you're just adding the y values together. That's it. You're just adding the y values together. So here, yes. And for the two functions, the domains have to overlap. Both functions, both functions have to exist on the same domain to perform the operation. So like, for example, here, if let's say for whatever reason there was a blip here and there was no point, well, then I could not find the sum of those 2 points because there was a blip. There's no y to add to another y. I hope that makes sense. I hate these videos because I need y'all's feedback. It's so much better in person. But y'all are doing so good. Thank you so much for your time. Really, you're doing so great. I'm proud of you. Okay, so the f plus g, if this is f, x cubed plus 2x plus 5, and this is g, 6 minus x, then we really are just adding the two functions together. This is x cubed plus 2x plus 5 plus 6 minus x. So f plus g, which is what this says right up here. So now we just combine like terms because we don't actually need the parentheses. So we have x cubed 2x minus x is plus x. And then plus 5 plus 6 is plus 11. That's it. So pause the video. I want y'all to do B, C, and D. You can do it. Play when you're ready. All right. So here, this is x cubed minus 2x, excuse me, plus 2x plus 5. Now minus 6 minus x. We have to be sure to distribute that negative. Distribute. So x cubed plus 2x plus 5 minus 6 plus x, combining like terms. That's x cubed plus 3x minus 1. Hopefully that's what you got too. Now here, let me change colors and just break it up a little bit. We're just multiplying the two together. So this is x cubed plus 2x plus 5 times 6 minus x. So you can distribute, and more distribution, or you can do the box method. X cubed plus 2x plus 5. So you have 3, what am I trying to say? Columns. 6 minus x and 2 rows. So remember that the inside each cell is the product. So this is 6x cubed, 12x, 30, and then negative x to the fourth. Oof, negative 2x squared and negative 5x. And now you just combine like terms. So we have this is equal to, inside here, make sure, negative x to the fourth plus 6x cubed minus 2x. Here's your 12 minus 5, so that is 7, plus 7x plus 30. Ta-da! 6x cubed minus plus 6x cubed minus 2x plus 7x plus 30. And that's it. You just multiply them together. So here, f divided by d, it really is just like the top minus the bottom. So x cubed plus 2x plus 5 divided by 6 minus x. That's it. This does not factor into a 6 minus x. We don't have to worry about that. Here, if this is all values of x, we're just x cannot equal 6. Right? Because we cannot allow the denominator to equal to 0. So set it equal to 0, and then you kick that number out. 6 minus x equals 0. Add the x over. Whoopsie. Add the x over. So x equals 6 makes a 0. So that's the number we kick out. Go up. Okay, moving right along. Composition of functions. So this is where, yeah, you have substitution. G goes into F. So if the composition of two functions, F and G is F composed of G of X equals F of G of X. So they're like nested. They're inside out. Also notate that this like O with open O, if you would, that is the symbol for composed. Okay. So F composed of G. So make sure you know what this means, just like you know what plus sign, division, right, subtraction means. You need to know what this composed symbol means. Okay, I might as well finish it off with multiplication. So they're nested. So left to right or like outside in, if you would. So when I'm learning, or I recommend that you go from its composition notation to its function notation. And then you just substitute as you go along. So this is f of g. Oh, but g is 3x plus 2. So now this is, f of 3x plus 2. Remember, go back to what we learned this a couple weeks ago. That means that for f, wherever there's an x, you're now inputting what? 3x plus 2. 3x plus 2 squared minus 2. Remember that we distribute this out. So this is 9x squared. Remember, combine and double to get the middle term. The operation drops. Combine and double. So combine 3 times 2 is 6x double 12x. And then square the last term to get the last term. Square the first term to get the first term. Square the last term to get the last term. Combine and double to get the middle. And then minus 2, minus 2, minus 2, minus 2. Combine like terms. So 9x squared plus 12x plus 2. Yay, go on. Okay, now I want you to try D composed of F. Pause the video, give it a give it a try, get your critical thinking juices going. Think for yourself. I really want you to try based off just the example you've seen, what little direction I've given you, see what happens. Okay. So, oh, sorry, I'm yawning. Please forgive me. Write it in composition notation. So G of f of x, right? So this is G of x squared minus 2, because remember that's what f of x equals. So now for G, wherever there's an x, what are we inputting? X squared minus 2, perfect. So 3 times x squared minus 2 plus 2. Remember, note in all cases, I didn't drop the parentheses until it was called for. So use your parentheses as your directions. So distribute the 3. So 3x squared minus 6 plus 2 is 3x squared, what, minus 4? One thing that I want you to take away, one thing that I want you to note, is that it was the same F, same G. But when I switch the pattern, when I have F of G and G of F, notice that they are not the same equation, not the same equation at all. So just because you've done one does not mean you've done both, okay? So note that F composed of G of X will not always equal G composed of F of X, okay? Sometimes they will. We like when they do. That's when they do, they're inverses of each other. And we're going to talk about the next lesson in section, what is that, 16? But just because you've done one way, do not assume that you've done the other way. Okay, so just keep that in mind when you're going through. Right now, if I want to evaluate F composed of G of negative 4, we can do it a couple different ways. One way is that we can think of it as this like leapfrog. Okay, this is F of G of negative 4, meaning that negative 4 goes into G. So that is G of negative 4. So you go up and say, okay, well, this is 3 of negative 4 plus 2. So let's see, 3 times negative 4 is negative 12, plus 2 is negative 10. So now 10 goes into F. This is F of 10. So this is 10 squared minus 2. Right? Yeah, sorry. I got confused from the cubic from the other page. Oh well. This is 100, minus 2, or 98. Or, right, so basically this is the leapfrog, right? This is your X. And then you just continue on moving right to left. Or since we already found F composed of G above, we know from above that F composed of G of negative 4, is 9 times negative 4 squared plus 12 times negative 4 plus 2. So 9 times 16 minus 48 plus 2 is 98. That's just because I just, multiplied and I took the sum of these numbers. So either way, both is perfect. Yay! Go us! And y'all are still doing so good. Thank you for your patience. 2 more pages. And then we're done with the video. Sweet freedom. Okay, so now here's the f, the square root of x minus 4. Here's g, x plus 3. Find each of the following and state the domain of each. Okay. So here, f of g of x. Again, I recommend that you start with with substitutions. So this is just f of x plus 3. And then x plus 3 goes into your root x minus 4. So this is root x plus 3 minus 4, which is the square root of what? Just x minus 1? So we know that for domain, right, we take x minus 1. We say, okay, you have to be greater than or equal to 0, because that's what it means, right? Square root can't have a negative under there. So x has to be greater than or equal to 0. That's the domain. Yay, so okay, now I want y'all to try B. Try B and C. Pause the video. Really try. Don't just like keep playing. But pause the video, try it on your own, and then press play when you're ready. Okay, so again, I recommend you just kind of move forward with the substitutions. So this is G of the square root of x minus 4, which now means that root x minus 4 goes into G. So this is root x minus 4 plus 3, which is, that's it. You can't go any further. There's no way to get that 3 under the root. It just can't happen. So that's it. So then domain, same thing. We can't have a negative under here. Domain, right? That's just take the guts of the root, say, okay, you have to be greater than or equal to 0. Well, in this case, x just has to be greater than or equal to 4. And g of g. Is that fine? Can we do g of x? Can I take the composition of the same function? Like, yeah, we can. Okay, so this is g of x. This is g of x plus 3, so that's what g equals. So now x plus 3 goes into x for g. Sorry, my brain was having a hard time with that one. X plus 3 plus 3. Because remember, this is the x. Right where my finger is for g is the x, which is just x plus 6. So then the domain here is just all real numbers. So this is just a linear line with a slope of 1 and an intercept of 6. Sorry, I almost said equation. I was like, my brain is not working. So the domain is negative infinity to infinity for all real numbers, script R. Because that's just a linear equation. Sorry, I didn't mean to go off page. Okay, so for f of x is equal to 1 over x minus 2, and g of x is equal to the square root of x plus 4. Find f composed of g of x and state its domain. Okay, again, I want you to pause the video, really try on your own, and then play when you're ready. Okay, so this is f of g of x, or f of the square root x plus 4, or 1 over the square root of x plus 4 minus 2. Okay, so really the only thing we have to worry about is the domain for this square root right here in the denominator. So if you remember from what last week, what changes is that from above, if we took the gut and we said greater than or equal to, well, now we just take out the or equal to, because I can't divide by 0. So x is greater than -4 is the domain. Yay! All right, last example, and then 15 is done. So here's a function, h of x equals root 5 minus x squared. It's a composite of two functions f and g, such that h is equal to the composition of f composed of g of x. So basically this says, like, here's a function, I want you to break it down into the two sub-functions. Or basically what's an f and what's a g that gives us h. Keep in mind that this has g nested inside of f. So if y'all are going to tell me what's f and what's g, look here, and the inside function generally is inside of something, okay? And it's inside of parentheses, inside absolute value bars, inside square root. Hey, it might be inside a denominator or be the denominator, but these are your good examples for your inside function. So with that, what do you think G is? What's inside? Hopefully you said 5x minus, or 5 minus x squared. So then I like to put my finger here, and then if you pose your finger as an x, then that is just your outside function. Okay, so root x. And that's it. That's how you split them apart. Just make sure you recognize what function is inside, what function is outside, and then your inside function is generally and literally inside of something else. And there you go. Ta-da! Okay, y'all have an awesome day.